Now, in this lecture, we will find the area of the green triangle. In the drawing, we have triangle ABC it is an equilateral triangle, and inside triangle ABC we have the green triangle EDF. We know that BD equals to 2 units, DC equals to 4 units, and also AF equals to BF, and we want to find out the area of the green triangle FED. So, as you have already know, all the angles in an equilateral triangle equals to 60 degrees. So this angle is 60 degrees. Also angle CBA is 60 degrees, and also angle BCA equals to 60 degrees, and all the sides of an equilateral triangle are equal to each other. That is to say, AB equals to BC, equals to AC. Okay. AB equals to BC equals to AC. But we know that BD equals to 2 units and DC equals to 4 units. So BC will be equal to BD plus DC. That is to say, BC equals to 2 plus 4 units, so BC equals to 6 units, and also it is the size of AB and AC. All the sides of triangle ABC, that is an equilateral triangle, equal to 6 units. Okay. We will define FD as A. That is to say, FD equals to A, and then we will define DE as B. DE equals to B, and we will find out, first of all, we know that AF equals to BF and AC equals to 6 units. Okay, AC equals to 6 units and AF equals to BF. So if we define AF as X, then AF equals to BF, so BF will be also equal to X. So actually AB equals to AF plus BF, that is to say AB equals to X plus X, or AB equals to 2X, but we know that AB equals to 6 units because all the sides of the equilateral triangle ABC equals to each other, and the sides of triangle ABC equals to 6 units. So AB also equals to 6 units. So we got this equality that 2x equals to 6 units. 2x equals to 6 units. We can divide this equality by 2 and we will get that x equals to 3 units. So AF equals to 3 units and BF also equals to 3 units. Okay, in the next step we will find the value of A by using the law of cosines. What is the law of cosines? Actually, if we have a triangle this side of the triangle equals to A, this side equals to B, and the angle between side A and side B, the angle between side A and side B of the right triangle equals to theta, and this side of the right triangle equals to C. Then, according to the law of cosines, according to the law of cosines, c squared equals to a squared plus b squared minus 2 times ab times cosinus theta. So actually the law of cosines states that in any triangle c squared equals to a squared plus b squared minus 2 times ab times cosinus theta. It is true for any triangle. Okay, so we actually can implement the law of cosines in our drawing in triangle BFD. In triangle BFD, this triangle FD square, according to the law of cosines, FD square will be equal to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Again, in triangle BFD, according to the law of cosines, FD square equals to BF square plus BD square minus 2 times BF times BD times cosinus 60 degrees. Okay, FD square equals to BF square plus DB square minus 2 times BF times DB times cosinus 60 degrees. Okay, but we defined FD as A, so we can substitute FD by A. So we will get that A square equals to BF. We know that BF equals to BF square. BF equals to 3 units, so BF square is 3 square, and 3 square is 9, plus BD square. BD equals to 2 units, so BD square is 2 square, so 2 square is 4, minus 2 times BF times BD. It is 3 times 2, times cosinus 60 degrees. Cosinus 60 is 1 over 2. So in total we got that A square equals to 9 plus 4 minus 2 times 3 times 2 over 2. Here we have 2 in the numerator and we have 2 in the denominator, so 2 is cancelled. So in total we will get that A square equals to 9 plus 4 is 13, minus 2 times 3 is 6. Okay, so A square equals to 13 minus 6. 13 minus 6 is 7. So we got that A square equals to 7. We will take a root out of this equality and we will get that A equals to root of 7 units. So the value of A is root of 7 units. Okay. In the next step, we will define angle BFD as alpha, angle DFB will be defined as theta, angle EDC will be defined as gamma, and angle DEC will be defined as beta. Okay? And we will find the value of sinus theta according to the law of sines. What is the law of sines? The law of sines. Actually, if we have a triangle this side is of the triangle is A, this side is B, this side is C, and this angle is alpha, this angle is beta, and this angle is gamma. So the rule applies to any triangle. So the following relationship exists between the sides of the triangle to the angles of any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. This equality is true for any triangle. Okay, so according to the law of sines, in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, in any triangle, this relationship exists. So we will implement the law of sines in triangle BFD. Again, we will implement the law of sines in triangle BFD, this triangle. In triangle BFD, BD over sinus theta equals to FD over sinus 60 degrees. I will repeat again. B in triangle FBD, BD over sinus theta equals to FD over sinus 60 degrees. Okay, according to the law of sines, BD over sinus theta equals to FD over sinus 60 degrees. Okay, BD equals to 2 units, 2 units over sinus theta equals to FD, FD equals to root of 7 units, and sinus 60 degrees equals to the root of 3 over 2. Okay, so in total we got that 2 over sinus theta 2 over sinus theta equals to the root of 7 over root of 3 over 2. Here we can put 2 in the numerator and root of 3 in the denominator of this expression. Okay, we will get the 2 over sinus theta equals to 2 times root of 7 over root of 3. Okay, here we delivered 2 to the numerator and root of 3 to the denominator. We got that 2 over sinus theta equals to 2 times root 7 over root 3. We have 2 in the numerator of this side of the equality, and we have 2 in the numerator of the other side of the equality, so we can cancel 2, and we will get that 1 over sinus theta equals to the root of 7 over root of 3 Okay, we got that after we cancel 2, we got that 1 over sinus theta equals to the root of 7 over root of 3. Here we can multiply this equality by root of 3. We will get that root of 3 over sinus theta equals to root of 7 after we multiplied this equality by root of 3, we got that root of 3 over sinus theta equals to root of 7. Now we will multiply this equality by sinus theta. So after we multiply this equality by sinus theta, we got that root of 3 equals to the root of 7 times sinus theta. In the next step, we will divide this equality by root 7, and we will get that sinus theta equals to the root of 7 over root of 3. So I made a mistake. Actually, here we divide this equality by root of 7 in order to get the value of sinus theta. Again, we will divide this equality by root of 7 in order to get the value of sinus theta. So sinus theta will be equal to the root of 3 over root of 7. So after we divided this equality by root of 7, we got that sinus theta equals to the root of 3 over root of 7. Okay, in the next step we will get the value of cosinus theta by using a trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. So we will use the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Here, in this trigonometric identity, we can subtract from this equation sinus theta squared from both sides of the equation. So we subtracted the sinus theta squared from this equation. We got that cosinus theta squared equals to 1 minus sinus theta squared. In the next step, we will take a root out of this equality, and we will get that the value of cosinus theta equals to the root of 1 minus sinus theta squared. Okay, we took a root out of this equality and we got that the value of cosinus theta equals to the root of 1 minus sinus theta squared. Okay, but we know that sinus theta equals to root of 3 over root of 7. We know that sinus theta equals to root of 3 over root of 7. So actually, if sinus theta equals to the root of 3 over root of 7, then the value of sinus theta squared will be equal to 3 over 7. Okay, the value of sinus theta squared will be equal to 3 over 7. I write it down. The value of sinus theta squared will be equal to 3 over 7. Okay, the value of sinus theta squared equals to 3 over 7. So actually we can substitute sinus theta squared in this equality by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, so we will get that the value of cosinus theta equals to the root of 1 minus 3 over 7. Okay, we substituted sinus theta squared by 3 over 7 in this equation, and we got that cosinus theta squared equals to 1 minus 3 over 7. 1 minus 3 over 7 equals to 4 over 7. Okay, so we can write down that the value of cosinus theta equals to the root of 4 over 7, because 1 minus 3 over 7 equals to 4 over 7. So we actually got that the value of cosinus theta equals to the root of 4 over 7. But the root of 4 is 2, so you can write here that the root of 4 is 2. So cosinus theta will be equal to 2 over root of 7. Okay, the root of 4 is 2, so in total we got that cosinus theta equals to 2 over root of 7, and we have already found that the value of sinus theta is actually root of 3 over root of 7. Okay, so we have already found that sinus theta equals to the root of 3 over root of 7, and we found also that cosinus theta equals to 2 over root of 7. Okay, so we found out the values of sinus theta and cosinus theta, and in the next step we actually know that the sum of the angles in any triangle equals to 180 degrees, and it is actually true especially in triangle BFD. The sum of the angles in triangle BFD equals to 180 degrees. That is to say, 60 degrees plus alpha plus theta equals to 180 degrees. So that will be our first equation that states that the sum of the angles in triangle BFD equals to 180 degrees. So we will get that 60 degrees plus alpha plus theta equals to 180 degrees. Again, the sum of the angles in triangle BFD in this triangle equals to 180 degrees. That is to say, 60 degrees plus alpha plus theta equals to 180 degrees. So that is our first equation. And we will create the second equation that states that the sum of the angles in triangle DEC equals to 180 degrees. So the sum of the angles in triangle DEC is actually 60 degrees plus gamma plus beta. 60 degrees plus gamma plus beta equals to 180 degrees. Okay, so our second equation states that the sum of the angles in triangle DEC equals to 180 degrees. That is to say, 60 degrees plus gamma plus beta equals to 180 degrees. Okay, that is our second equation. In the next step, we will add equation number 1 to equation number 2, and we will create the third equation. So we will add equation 1 and equation 2 together. Actually, 60 degrees plus 60 degrees is 180 degrees, plus alpha plus theta plus gamma plus beta will be equal to 180 degrees plus 180 degrees, that is to say 380 degrees. Okay, so I will write it down. So our third equation will be 60 degrees plus 60 degrees is 120 degrees, plus alpha plus theta plus gamma plus beta equals to 180 degrees plus 180 degrees equals to 360 degrees. Okay, so in total, according to the further equation, 180 degrees plus alpha plus theta plus gamma plus beta equals to 360 degrees. Here we will subtract 180 degrees from the further equation. Okay, we will get that alpha plus theta plus gamma plus beta equals to 240 degrees, because 360 degrees minus 120 degrees equals to 240 degrees. So in total we got in our further equation that alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, so we know that the sum of the angles in the upper side of any straight line or any line segment, the sum of the angles in the upper side of the line the line segments equals to 180 degrees. So we have side BC of the equilateral triangle. We know that the sum of the angles in the upper side of the straight line BC equals to 180 degrees. So we can write down our fourth equation that states that the sum of the angles in the upper side of any straight line or line segment equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, so fourth equation states that alpha plus 90 degrees plus gamma equals to 180 degrees. We can also say that the sum of the angles in the lower side of any straight line or line segment equals to 180 degrees. Okay, so our fourth equation states that the sum of the angles in the upper side of any straight line or line segments equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, here we will subtract 90 degrees from the fourth equation, and we will get that alpha plus gamma equals to 90 degrees. We got that after we subtracted 90 degrees from the fourth equation, we got that alpha plus gamma equals to 90 degrees. Okay? But in the third equation, we have alpha plus gamma. the third equation. So we actually can substitute alpha plus gamma in the third equation by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, we'll substitute alpha plus gamma in the third equation by 90 degrees. Okay, and we will get that 90 degrees plus theta plus beta, 90 degrees plus theta plus beta equals to 240 degrees. Okay, so we got in our third equation 90 degrees plus theta plus beta equals to 240 degrees. Here we'll subtract 90 degrees from equation number 3, this equation, and we will get that theta plus beta equals to 150 degrees. Okay, after we subtracted 90 degrees from this third equation, we got that theta plus beta equals to 150 degrees, because 240 degrees minus 90 degrees equals to 150 degrees. Okay, here in the third equation we will subtract theta from both sides of the equation, and we will get that beta equals to 150 degrees minus theta. So after we subtracted theta from equation number 3, we got that beta equals to 150 degrees minus theta. Okay, so if beta equals to 150 degrees minus theta, then we can say that sinus beta equals to sinus 150 degrees minus theta. Okay, so sinus beta will be equal to sinus 150 degrees minus theta. Okay, if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, what is the value of sinus 150 degrees minus theta? Actually, we calculate the value of sinus 150 degrees minus theta according to the second trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta times cosinus alpha. So we will use the second trigonometric identity in order to calculate the value of sinus 150 degrees minus theta. According to the second trigonometric identity, the value of sinus alpha minus beta equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, here alpha equals to 150 degrees and theta equals to beta. Okay, so we will get that sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. Okay, we used this trigonometric identity in order to calculate the value of sinus 150 degrees minus theta when alpha equals to 150 degrees and beta equals to theta. We got that sinus of 150 degrees minus theta equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus 150 degrees. But we have already found out the values of cosinus theta and sinus theta. Actually, we found that cosinus theta equals to 2 over root 7 and sinus theta equals to the root of 3 over root of 7. Okay? So we can write that all equals to sinus of 150 degrees is 1 over 2 cosinus theta is 2 over root of 7 minus sinus theta is root of 3 over root of 7 and cosinus of 150 degrees equals to minus root of 3 over root of 2. So in total we got that 1 over 2 times 2 over root of 7 minus root of 3 times root of 7 times minus root of 3 over 2. Here minus times minus is plus, and root of 3 times root of 3 is 3, so I write it down. And this equality is actually sinus beta, because we have sinus beta that equals to this equality. We started from sinus beta that equals to sinus 150 degrees minus theta that equals to this expression, so all of these are sinus beta. So we can write down that sinus beta equals to 1 over 2, 2 over root of 7, and minus times minus is plus, so we have here plus, and root of 3 times root of 3 is 3, over 2 times root 7. Okay, so in total we got that sinus beta equals to 2 over 7 plus 3 over 2 over 7. Okay, so we have 2 in the numerator of this expression and 2 in the denominator of this expression, so we can cancel 2, and we will get that after we cancel 2 that sinus beta equals to 1 over root of 7 plus 1 over root of 7 times 3 over 2. Okay, sinus beta equals to 1 over root of 7 plus 1 over root of 7 times 3 over 2. Here we can take 1 over root of 7 as a common factor of this expression. Okay, we will take 1 over root of 7 as a common factor of this expression. We'll take out 1 over root of 7 as a common factor of this expression, and we will get that sinus beta equals to 1 over root of 7. So we take a common factor of 1, we will take out a common factor of 1 over root of 7, and in the brackets we will get 1 plus 3 over 2. Okay, so in total we got that sinus beta equals to 1 over root of 7 times 1 plus 3 over 2. 3 over 2 is 1 and a half. 1 and a half plus 1 is 2 and a half. 2 and a half is 5 halves. Or 5 over 2 is 2 and a half. Okay, so we write it down that sinus beta equals to 1 over root of 7 times 5 over 2. Okay, so we actually got the value of sinus beta that equals to 5 over root of 7 times 2. Okay, so we found out the value of sinus beta, and in the next step we will focus on triangle DEC. On triangle DEC, according to the law of sines, DE over sinus 60 degrees equals to DC over sinus beta. Okay, DE over sinus 60 degrees equals to DC over sinus beta. DC over sinus beta. Okay, we implemented the law of sines in triangle DEC. According to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. You should remember that we found out the value of sinus beta. Okay, we have already found out the value of sinus beta. So, according to the law of sines, DE over sinus 60 degrees equals to DC over sinus beta. DE over sinus 60 degrees equals to DC over sinus beta. But the value of DE is B. According to our definition, the value of DE is B. And sinus 60 degrees is root 3 over 2. And DC equals to 4 units. And sinus beta equals to 5 over root of 7 times 2. Okay, so here we substituted DE by B because DE equals to B. DE equals to B according to our definition. Sinus 60 degrees is root 3 over 2. So we substituted sinus 60 degrees by root of 3 over 2. and DC equals to 4 units, and sinus beta equals to 5 over root of 7 times 2. Okay, so here we will put 2 in the numerator and root of 3 in the denominator, and we will also put root of 7 times 2 in the denominator, and we will put 5 here in the denominator. Okay, it is very simple arithmetic. We will get that 2 times b over root of 3 equals to root of 7 times 2 times 4 over 5. Okay, we did this simple arithmetic here, and we got that 2b over root of 3 equals to root 2 times 4 over 5. Okay, so we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. So what left after we cancelled 2? We'll have b over root of 3 equals to the root of 2 times 4 over 5. So after we cancel 2, that is what is left, that b over root of 2 equals to the root of 2 times 4 over 5. Here we'll multiply this equality by root of 3 in order to get the value of b. Okay? So after we multiply this equality by root of 3, we got that b equals to the root of 3 times root of 2 times 4 over 5 units. Okay, but we have already found out that the value of a is root 7, and the area of any triangle is the base of the triangle times the height to the base over 2. And the area of triangle FDE will be the base of the triangle, that is b, times the height to the base, that is a, over 2. You should remember that the height must create 90 degrees with the base, and here the height FD creates 90 degrees with the base DE, that is b. Okay, so the area of the green triangle FDE equals to a times b over 2. Okay, the area of triangle FDE, the green triangle, equals to a times b over 2. Again, the area of the green triangle FDE equals to a times b over 2. Okay, so the area of triangle FDE equals to A. A is root 7. We found out that A equals to the root of 7 times B. We found out that B equals to the root of 3 times root of 2 times 4 over 5, and all divided by 2. Okay, so the area of the green triangle FDE equals to the root of 7 times root of 3 times root of 2 times 4 over 2 times 5. So here we have 4 over 2 is 2. Okay, actually we have here B equals to the root of 7 times root of 2 times 4 over 5. So the area of the triangle equals to A times B over 2. So here we will get that A is root of 7 times root of 7 times root of times 4 times root of 7 over 5 and 2. So in total we got that the root of 7 times root of 7 is 7, and 4 over 2 is 2, so the area of triangle FDE equals to 7 times 2 times root of 3 over 5. Okay, so the area of triangle FDE, the great triangle, equals to 7 times 2 times root of 3 over 5. 7 times 2 is 14. So the area of the great triangle FDE equals to 14 times root of 3 over 5 square units. We got that the area of the great triangle FDE equals to 14 times root 3 over 5 square units. So in terms of numbers, the area of the great triangle FDE equals to 4.85 square units. Okay, so the area of this great triangle equals to 4.85 square units. Okay, now I summarize the lecture. Actually, we wanted to find out the area of the great triangle FDE. We have triangle ABC that is an equilateral triangle, and we know that BD equals to 2 units, DC equals to 4 units, and AF equals to BF. Okay? And we want to find out the area of the great triangle FDE. Okay? First of all, we know that all the angles in an equilateral triangle equals to 60 degrees, so angle BAC is 60 degrees, angle CBA is 60 degrees, and angle ACB is also 60 degrees. And all the sides in an equilateral triangle are equal to each other, so AB equals to BC equals to AC. But we know that BD equals to 2 units and DC equals to 4 units, so BC equals to BD plus DC. So actually BC equals to 2 plus 4, or BC equals to 6 units. So we can say that AB equals to BC equals to AC equals to 6 units. Okay, so the sides of the equilateral triangle ABC equals to 6 units, and we know it is given us in the question that AF equals to BF. Okay, So we defined AF as x, and if AF equals to x and AF equals to BF, so BF also will be equal to x. So the size of AB is AF plus BF. That is to say, the size of AB equals to AF, that is x, plus BF, that is also x. So the size of AB equals to 2x. Okay, but we know that the size of AB equals to 6 units. So we can write down that 2x equals to 6 units. And we divide this equality by 2, and we got that x equals to 3 units. So the value of BF is 3 units, and the value of AF is also 3 units. And in the next step we defined FD as A and DE as B, and we found the value of FD, that is A, according to the law of sines, the law of cosines. What is the law of cosines? In any triangle, if this side of the right triangle is A, this side is B, and this side is C, then C square equals to A square plus B square minus 2 times AB cosinus theta. Okay, so we implemented the law of cosines in triangle BFD. In triangle BFD, FD square equals to BF square plus BD square minus 2 times BF times BD cosinus 60 degrees. Okay, in triangle, the small triangle BFD, FD square equals to BF square plus DB square minus 2 times BF times BD cosinus 60 degrees. That is the implementation of the law of cosines in triangle BFD. Okay. FD square equals to BD square times BF square minus 2 times BF times BD cosinus 60 degrees, according to the law of cosines. Okay, but according to our definition, FD equals to A, FD equals to A, BF equals to 3 units, BF equals to 3 units, and DB equals to 2 units. So the only missing variable here is FD that equals to A. We know all the other values of all the line segments here. So the only missing variable is A. So we solve this equality, the equality of the law of cosines, and we found out that A equals to the root of 7 units. Okay, A equals to the root of 7 units, and then we defined angle BDF as alpha, angle BFD as theta, angle EDC as gamma, and angle DEC as beta. And again, we have the law of sines that states that in any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, So we actually implemented the law of sines in triangle BFD, the small triangle BFD, and according to the law of sines, BD over sinus theta equals to FD over sinus 60 degrees. Okay, so in order to find out the value of sinus theta, we implemented the law of sines in triangle BFD. According to the law of sines, BD over sinus theta equals to FD over sinus 60 degrees. Okay? According to the law of sines in triangle BFD, BD over sinus theta equals to FD over sinus 60 degrees. And we know that BD equals to 2 units, FD equals to the root of 7 units, and sinus 60 degrees is root of 3 over 2. Okay? And we have all the values of all the line segments here, and we found out by solving this simple equality that the value of sinus theta is root of 3 over root of 7. Okay, so the value of sinus theta is root of 3 over root of 7, and we also found out the value of cosinus theta by using the trigonometric identity, the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We subtracted sinus theta squared from this formula. We got that cosinus theta squared equals to 1 minus sinus theta squared. Then we take a root out of this equality. We took a root out of this equality, and we got that cosinus theta equals to the root of 1 minus sinus theta squared. Okay, but we know that sinus theta equals to the root of 3 over root of 7. So if sinus theta equals to the root of 3 over root of 7, then sinus theta squared will be equal to 3 over 7. So we can substitute sinus theta squared in this equation. We can substitute sinus theta squared by 3 over 7 because sinus theta squared equals to 3 over 7. Okay, so we substituted sinus theta squared by 3 over 7. We got that cosinus theta equals to 1 minus 3 over 7, because sinus theta squared equals to 3 over 7. Okay, cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. Okay, so we got that cosinus theta equals to the root of 4 over 7, and the root of 4 is 2, so we got that cosinus theta equals to 2 over root of 7. And we already found out that the value of sinus theta is the root of 3 over root of 7. Okay, and then we know that in any triangle, the sum of the angles in any triangle equals to 180 degrees. Okay, and we found out, so we created equation number 1 by the state that the sum of the angles in triangle BFD equals to 180 degrees, and also, so in this way we created our first equation, and our second equation was that the sum of the angles in triangle DEC equals to 180 degrees. This was our second equation, and our fourth equation was the state that the sum of the angles in the upper side of a straight line is 180 degrees, so alpha plus 90 degrees plus theta equals to 180 degrees. So in this way we created 3 equations. Okay, so we got from the third equation that beta equals to 150 degrees minus theta, and if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta, and we found out the value again. We created the first equation that states that the sum of the angles in triangle BFD equals to 180 degrees. That is to say 60 degrees plus alpha plus theta equals to 180 degrees. And then we created the second equation that states that the sum of the angles in triangle DEC equals to 180 degrees. That is to say gamma plus 60 degrees plus beta equals to 180 degrees, or 60 degrees plus gamma plus beta equals to 180 degrees. We added equation now 1 and equation 2 together, and we got the third equation. And again, the fourth equation was the statement that the sum of the angles in the upper side of a straight line or line segment equals to 180 degrees. That is to say alpha plus 90 degrees plus gamma equals to 180 degrees. So the fourth equation was alpha plus 90 degrees plus gamma equals to 180 degrees. Okay, and we actually found that beta equals to 150 degrees minus theta. If beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. And in order to find out the value of sinus 150 degrees minus theta, we used the second trigonometric identity that states that the value of sinus alpha minus beta is sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, so we use this trigonometric identity in order to find out the value of sinus 150 degrees minus theta, and this is equals to sinus beta. And we found out that the value of sinus beta equals to 5 over root of 7 times 2. Okay, so after we know the value of sinus beta, we can calculate the value of b, because actually dc over sinus beta equals to dE, that is b, over sinus 60 degrees. Okay, so according to the law of sines, dE over sinus 60 degrees, dE over sinus 60 degrees equals to dc over sinus beta, equals to dc over sinus beta. Okay, and we know all the values of all the line segments here, and dc equals to 4 units, dE equals to b, it is the only missing variable. So, and we know the value of sinus beta. So we found out that b equals to the root of 7 times root of 2 times 4 over 5. And we have already found out that the value of a is root 7. And the area of the green triangle is the base of the triangle times the I to the base over 2. So the area of the green triangle FDB equals to A times B over 2. And A equals to the root of 7, and B is this expression. So A times B over 2 is actually 14 times root of 3 over 5 square units. So in terms of numbers, the area of the green triangle equals to 4 over 4.85 square units. The area of the green triangle FDE equals to 4.85 square units. Okay, thank you very much.